Let's now take this other question on limit. We have limit as x approaches 0 of e to the 2x minus 1 all over e to the x minus 1. Our function here is actually a rational function. There is a numerator and there is a denominator. And so there is a theorem on limits, which is called the quotient limit theorem, applicable to rational function. So we'll start by using the quotient limit theorem to see if it is applicable. And in a case where it's not applicable, then we'll now resort to other methods. Okay. Let's look at the solution. Okay, we have limit as x approaches 0 of e to the 2x minus 1 all over e to the x minus 1. Now, the quotient limit theorem says that we should apply the limit point 0 on our function directly and see what we get. Now, if we do that, okay, so using the quotient limit theorem, using the quotient limit theorem, that limit becomes limit as x approaches 0 of our limit point is 0. As x approaches 0, our limit point is 0, so we'll put it there and see what we get. Now, this will be equal to anything raised to the power 0 is 1. So we have 1 minus 1 all over 1 minus 1, which gives us 0 over 0. And 0 over 0 is indeterminate. Indeterminate, no conclusion. We have no conclusion. 0 all over 0 is no number. So we don't have any answer when we apply the quotient limit theorem. So finally, therefore, we have now to resort to other methods. Other methods could include algebraic simplification or we either use algebraic simplification or we use the L'Hopital's rule. All right, we're going to demonstrate the two methods to see. Now, let's start with the L'Hopital's rule. Method 1, L'Hopital's rule. To apply the L'Hopital's rule, it says that limit as x approaches 0 of e to the 2x minus 1 all over e to the x minus 1, that limit is the same as the limit when we take separate derivatives of the numerator. When we take separate derivatives of the numerator, dx of the numerator and separate derivative dx of the denominator. That is what the L'Hopital's rule says. Now let's go ahead and evaluate. So we have limit as x approaches 0. When we differentiate that numerator there, we're going to have 2e to the 2x. We're going to have 2e to the 2x all over e to the x. Now, when we apply x equals 0, our limit point, we're going to have 2 into e to the 0 all over e to the 0, which is just going to give us 2 into 1 all over 1, which is 2. So, with L'Hopital's rule, we obtain that our limit is 2. Now, that is method 1. Method 1. Now, what is method 2? Method 2 is algebraic simplification. Method 2, algebraic simplification. We realize that the numerator of our limit as x approaches 0 of e to the 2x minus 1, that numerator is actually a difference of 2 squares, because we can write it as limit as x approaches 0 of e to the x squared minus 1 all over e to the x minus 1. That's what we get. So we actually see, remember 1 can also be written as 1 squared. So at the numerator, we'll have a square minus a square, difference of 2 squares. So when we now apply the difference of squares identity, that limit becomes limit as x approaches 0 of e to the x minus 1 into e to the x plus 1. All of that divided by e to the x minus 1. Now this one cancels that. And our limit finally becomes limit as x approaches 0 of e to the x plus 1. This gives us e to the 0 plus 1, which is 1 plus 1, which again is 2. So whichever method we use, we come up with the same answer. We either use algebraic simplification or we use the L'Hopital's rule.